The purpose of this podcast is to educate and inform. It is no substitute for professional care by your doctor or your qualified healthcare professional. Never disregard or delay professional medical advice because of something you've heard on this podcast or in any linked material. Guests who speak on this podcast express their own opinions, experience, and conclusions. Dr. Shirley neither endorses nor opposes any particular opinion discussed on this podcast. The views expressed on this podcast have no relation to those of any academic, hospital, practice, institution, or other entity with which Dr. Shirley may be affiliated.
Welcome to Forever Fab, the podcast on fashion, the art of living, and all things beauty. This podcast is curated by Dr. Shirley Madere, MD, as the definitive source of holistic wellness through beauty.
Welcome to Forever Fab, the podcast dedicated to fashion, the art of living well, and all things beauty. I'm your host, Dr. Shirley Madere, your purveyor of this definitive source of living a most beautiful life. So, they say you are what you eat. This week's episode examines the idea that you may also look like what you eat. Welcome to Fierce and Flawless, Nutrition and Beauty. So, first things first, I got to get my nerd on, and I just have to run down brief anatomy and physiology lessons. So here we go. Grab yourself a cup of green tea or white tea, chill out, kick your feet up, make sure your ear pods are in or your headphones are on because it's about to get academic. How is food processed? I mean, we're talking about nutrition, so we have to go back to how food is processed the minute it enters your mouth. So digestion begins in the mouth. You start chewing your food, you break it down, it mixes with saliva, and that contains enzymes to help break the food down. And then muscular contractions and all that, your tongue brings it back and down into your throat. Muscular contractions in the esophagus push the food into the stomach. So food goes into the mouth, then it goes into the throat, and then in the esophagus, and the muscular contractions in your esophagus push the food down into your stomach. Once in the stomach, powerful enzymes and acid continue the process of breaking down that food. And once that food is further broken down, it enters, again through muscular contractions, enters into the small intestine. The small intestine also continues the process of breaking down food by, familiar theme, enzymes. So more enzymes are released, this time by the pancreas, and also by bile from the liver. So you have enzymes from the pancreas, and you also have bile from the liver continuing to break down the food in the small intestine. Now, bile is a compound that aids in the digestion of fat. So, bile is stored in the gallbladder. So basically, that bile helps eliminate waste products from the blood. The pancreas is an organ that is also involved in digestion. And as I mentioned, the pancreas secretes digestive enzymes. So there are a lot of organs involved in this whole system of digestion. It's really complex, but it's so beautiful. And I hope that you're getting an idea of how everything works and how everything is just a beautifully orchestrated symphony that ultimately helps us to function properly. So the pancreas is involved in digestion. It secretes and releases enzymes that also break down protein, fat, and carbohydrates. And basically, all those components are derived from the food that we eat. The liver secretes the bile, and the bile is stored in the gallbladder. So once the liver secretes the bile, it cleanses and purifies the blood coming from the small intestine containing those very nutrients that were just absorbed. And the liver is what's considered a master detoxifier. I know there are some of you who do liver cleanses, and it is actually pretty important because the liver is a master detoxifier, but every once in a while it needs some help to do its job properly. That being said, alcohol certainly affects the liver. So if you are someone who imbibes a little bit too much, then certainly look into either quitting altogether, just stopping and just saying no, or doing a liver cleanse every once in a while, under obviously medical supervision or specialist supervision. Okay, moving forward. So the gallbladder stores the bile, and during a meal, the gallbladder contracts and it sends the bile into the small intestine. Now, the food then gets promulgated into the large intestine or the colon. Waste that's left over from the digestive process is passed through the colon by means of peristalsis, or again, muscular contractions in the linings of those intestines. And first, that food waste is in a liquid state, and ultimately it becomes solid because the water is subsequently removed or reabsorbed from the leftover waste. Stool is the end result. And frankly, to a certain extent, we're all full of it until we get rid of it. So stool is stored in the sigmoid colon. That's just another part of the colon, right? And until it empties. So that stool is going to sit there until it empties. We're going to talk about transit time later because that really is important. Because your digestion could work beautifully, but then once it gets to the point where it's stored, if things aren't moving along, then you've got issues. So basically, stool is stored in that sigmoid colon until it empties. And it normally takes about 36 hours for the stool to get through the colon. But emptying or evacuation should take place at least once or twice a day. So even though the transit time is generally about 36 hours, it doesn't mean that your stuff should sit there for 36 hours, right? You should be evacuating at least once or twice a day. Elimination. So they say you are what you eat, but you really also are what you don't eliminate. So the process of elimination is as important as what you take into your body. So elimination is the rectum's responsibility. So the rectum's job is to receive the stool from the colon, and the rectum is pretty much at the very end of that colon. So it receives the stool from the colon, and to let you know there's stool to be evacuated and to hold on until you get the signal to actually evacuate. And that signal, comes from the brain. So you hold on to the stool until evacuation happens. And when anything, whether it's gas or liquid or solid, when anything comes into the rectum, there are sensors in the rectum that basically communicate to the brain and send a message to the brain and let the brain know, yes, it's okay to release, or no, please don't do this right here. So believe it or not, digestion, and especially that rectal area and your anus, it's really a complicated and yet intelligent, and in a funky kind of way, a beautiful process. I know there's some people, I wonder if that gives a new meaning to the phrase, get your head out of your ass, or, why are you being so anal? I'm not really sure if they have anything to do with each other, but I'm just saying that digestion is really a beautiful process. And if you can honor your temple in such a way that you can make sure that your digestion prospers functionally, then life will certainly be beautiful. Moving on. The lining of the upper anus is specialized. As I was saying, it's a complex and intelligent process. So the lining of the anus is actually specialized to detect material in the rectum. So believe it or not, you've got a brain up your ass also. You've got a little bit of a brain in there also that basically detects whether or not what is being held is liquid, gas, or solid. So, very important that everything works properly. The pelvic floor muscles stop stool from coming out when it's not supposed to. So again, you have the anus and the rectum and the intestine connected to energetically and by means of chemical hormone messengers. Everything is related and connected. So if your brain says, don't go, then the pelvic muscles will contract and basically lead you to hold. Okay. The internal sphincter keeps you from going to the bathroom when you're asleep or otherwise unaware of the presence of stool. So when we get an urge to go to the bathroom, the external sphincter is what keeps the stool in place until we can get to the bathroom, or we can get to a place where it's actually appropriate to let it all out. So digestion is not only a complex, sophisticated, and intelligent process, it is also integrated with the pelvic floor, pelvic muscles, abdominal muscles, the brain, and the bloodstream. So in and of itself, digestion is a holistic process that is critical to health, critical to wellness, and I would argue critical to beauty. But how is digestion related to beauty? I mean, you can understand how digestion is important to health and wellness, but really, beauty, am I really stretching it? Yes, and I'm about to explain how. You are what you eat, and as I mentioned, you are also what you do not eliminate. And let's talk about transit time. I mentioned that earlier. The definition of intestinal transit time is the amount of time it takes for stuff, food materials, food particles, etc., to move through your intestines. And typically we speak of colonic transit time because, again, small intestines and all the other organs contribute to digestion. But when we talk about transit time, we're really speaking primarily of sort of that last part of the intestines or the colon. And generally that takes 30 to 40 hours, and it can take longer in women. Boy, women really bear the burden of society, don't we? Anyway, so 30 to 40 hours of colonic transit time, and sometimes longer in women. Proper gastrointestinal function is essential for digestion and metabolism of nutrients and, as explained previously, for a strong immune system. Excessively slow transit time, so if it's taking 40 plus, 50 plus hours for foodstuff and waste to transfer or move through your colon, that's called a slow transit time. So an excessively slow transit time is also called constipation. And that reduces the processing of food, it reduces the processing of complex carbohydrates, and unfortunately what happens is potentially all the food waste that's hanging out there in the colon, all those toxins in that waste can be reabsorbed. And this reduced function leads to decreased production of the substrate or the material that the intestinal cells and the whole body, all those nutrients that are needed for energy by the colon cells. So a long transit time reduces energy and reduces nutrition to your colon cells. There was a study about slow transit time, and basically it's talked about the nutrients in the colon and from the food that's being processed. Those nutrients actually serve as substrate or energy for the colon cells, and a slow transit time actually reduces that energy. So basically, you can see how decreased transit time, malabsorption, poor digestion can ultimately lead to inflammation and chronic disease processes. Okay. Excessively slow intestinal transit time may also lead to something called oxidative stress, and I'll talk about that a little bit later, and increased inflammation. So what that means is that the toxicity and the toxic materials in the stool, one of them is ammonia, that can be reabsorbed by the intestinal tract and then enter the blood circulation. Now, there's some uses for ammonia in chemical processes that help the body to function properly, but excessive amounts of ammonia actually can affect the brain and lead to anything from mental fog, decreased clarity, to brain damage. So you definitely want to be able to get rid of your ammonia. Ammonia, for example, is produced by the breakdown of proteins in the food from the amino acids. And inefficient removal of that ammonia may lead to reabsorption of the blood, and again, as I mentioned, may affect the brain. In addition, the abnormality of slow intestinal transit time would also cause imbalance of the intestinal flora. Now, I want to get to the intestinal flora because in a later part of the podcast, or maybe in a separate podcast, I am going to talk about the intestinal flora, or the microorganisms that constitute every part of our being. So the intestinal flora is also referred to as the microbiome or the microbiota. So slow intestinal transit time could also cause an imbalance in this microbiome or in this flora. That can directly interact with your DNA, like the stuff that makes you, your specific unique code, your DNA. So that slow transit time can affect your microbiome. Your microbiome imbalance can then affect your DNA, and then that DNA can be damaged. And the damage to your DNA would obviously ultimately lead to damage to other structures and other proteins in the body, and that could lead to a whole host of issues. Another example of a protein is collagen. Collagen and also elastin, those two are critical proteins for the skin. Collagen makes up about 75 to 80% of the skin. Both collagen and elastin are responsible for keeping the skin firm and taut and wrinkle-free. And unfortunately, we lose that as we age. And I'm not sure if any amount of collagen drinking could help to restore that, unfortunately. If anybody out there has a collagen drink that actually works, send it to me. 594 Broadway, Suite 204, New York, 10012. Both collagen and elastin are responsible for the integrity and the health of your skin. If rampant protein damage is occurring as a result of the toxic materials that are being reabsorbed from your intestines from a slow or excessively slow transit time, then your skin would age prematurely. And that would potentially lead to acne if you didn't have it before your wrinkles. And then your skin would start to look dull and sallow. So here's the connection. The food that you eat can affect how you digest. If you don't digest well, that can affect how you look. So yes, food is important, and especially what you're putting into your body and how you digest it as an individual is important. Here's another protein, keratin. Since we're talking about beauty, let's cover it all. Keratin is a structural protein in hair. It's also in skin and your nails. Damage to this protein, also as a result of poor digestion, damage to the keratin would result in loss of hair integrity. It would result in damaged hair, and ultimately it could result in hair loss. My God, that is awful. That's awful. So if your keratin is damaged, then you would have a loss of integrity of your hair. You'd have a loss in the rigidity of your skin and your hair. You could lose the skin's barrier function, and possibly, as I mentioned, you'd have hair loss. No, thank you. And I know there are lots of ways to camouflage hair loss, but frankly, whether you camouflage it or not, whether it's wigs or extensions or whatever it is that you're doing, ultimately, underneath all that, you really want healthy hair. So that when you decide to stop with the trends and the fads and the coloring and the this and the that and the other, you at least have your beautiful hair as it was meant to be, nice and healthy and strong. I mentioned earlier oxidative stress. There are lots of stressors in the world. There's lots of stress in the world, especially now. But I'm going to talk about physiologic stuff, like nerdy stuff, academic stuff, oxidative stress. Oxidation is a normal process, and it's necessary for the body to function properly. It's a chemical reaction that can produce, however, free radicals. Free radicals are these elements, right? They're these electrons. There's these things that are just kind of hanging out, waiting for some action, looking for a party. These free radicals can lead to chain reactions that may potentially damage the cell if the free radicals do their thing, but do it excessively or poorly and go unchecked. Free radicals, when they function properly, can help fight pathogens and infections that can create, illness. Antioxidants, we talked about oxidation. Antioxidants are substances that keep those free radicals in check. So again, oxidation is normal. Free radicals can have normal function, but when either of those processes or either of those elements go unchecked and go wild, then you can have problems. So antioxidants help keep those free radicals in check and help keep everything in balance. Antioxidants are the compounds that inhibit oxidation. Okay, again, oxidation when it goes crazy. Oxidative stress is an abnormal process, and that occurs when there's an imbalance between the free radicals and the antioxidant activity. So there's this battle going on. And when there is this imbalance and there are more free radicals that can be kept in check by the antioxidants, then the free radicals can harm tissues, can harm organs, can harm DNA and other proteins in the body. Here's another study for you. NIH, National Institutes of Health. According to an NIH study, oxidative stress has been observed in patients with constipation. So you would think, oh my gosh, we're talking about oxidative stress. That sounds really dramatic, and that sounds like it's in people who are sick. But no, oxidative stress has been linked or found in people who have slow transit time. It's also been found in those people with colorectal cancer, cardiovascular disease, and other chronic illnesses. So you would think, oh my gosh, so what? I don't go every day. But hello, the NIH found that there's a correlation between slow transit time or constipation and all these major drama diseases. So yeah, you got to keep it moving, folks. So how does oxidative stress occur? Well, I'm going to let you know, because maybe you're thinking, oh no, everything is fine. I'm not stressed. I have a lovely life. And B, I don't have oxidative stress. But there are a number of ways that you can get oxidative stress. One of them is emotional stress. Elevated cortisol levels, again, from stress. Toxic exposure, whether it's to mercury or metals or lead, pollution, smoke, exhaust fumes. Elevated blood sugar levels. Oh my gosh, weren't we just having a conversation about my addiction to sugar? I've got to stop. So elevated blood sugar levels can lead to oxidative stress because, excess circulating sugar in your body can coat proteins. It's called glycosylation of proteins. And if those proteins are being burdened, right, it's like having this albatross around your neck or just having this monkey on your back. The sugar is hanging out on your proteins and changing them and deforming them and making them do not cute things. One of them, premature aging. The other way that you can get oxidative stress is not enough antioxidants like vitamin C or vitamin E or selenium or zinc. And if you don't get enough of that stuff in your diet, if you don't get enough antioxidants from your natural diet, or if your diet is lacking, then maybe supplements. But I'm just saying, if you're not getting enough of those antioxidants, then your free radicals have the potential to go cray-cray. And another way you can get oxidative stress is physical stress. Believe it or not, like intense workouts, intense high-intensity workout, and other injuries. However, the difference in intense high-intensity workouts is that if you are feeding yourself well and you're healthy, then your body can manage that and recover quickly and manage to quell the oxidative stress. If you're not healthy, if you're not feeding your body well, if you're not resting, if you're not reducing stress in other aspects of your life, then your body may not be able to recover as quickly. And we're going to talk about a little bit more about oxidative stress and results later. So oxidative stress affects every cell in your body, including those intestinal cells. Proper gastrointestinal function or proper digestion is essential for the metabolism of nutrients to be able to feed all your cells in the body. Unbalanced, unchecked, or disrupted digestion or disrupted oxidative stress influences your gut microbiome or that intestinal flora or the microorganisms that live throughout our entire body. And those gut microbiome can be downregulated or they can cause their function to change in the intestines. And that can affect your intestinal barrier function. Okay. And once your intestinal barrier function is affected, that can also affect your mucosal immunity. And all of this will start to make a little bit more sense as I go on. So when the integrity of the gut is compromised, it can lead to what is known as leaky gut or intestinal permeability or dysbiosis. They all kind of mean the same thing. And that's when the body is no longer able to protect itself against the outside insults. And those outside insults could be undigested food, gluten, dairy for some people, and bad bacteria. So if the gut can no longer protect itself and serve an effective barrier function against the external environment, what will happen is that the toxins and the toxic materials will be allowed to pass through the disrupted barrier function of the intestines. So that disrupted barrier function will have sort of these holes, and these holes will allow all that toxic material to seep back out of the intestines and into the bloodstream. And that may be associated with a number of diseases such as celiac disease, Crohn's disease, irritable bowel syndrome, autoimmune diseases like lupus, Hashimoto's, Graves' disease, multiple sclerosis, chronic fatigue syndrome, fibromyalgia, arthritis, allergies, asthma, acne, thyroid disease, obesity, even mental illness. Shall I go on? I think you get the point, so I won't. So we talked about digestion. We've talked about the gut microbiome. We've talked about disruption of that microbiome. We talked about oxidative stress. Stay with me and stay tuned for more of Flawless Face.
You've just listened to part 1 of Forever Fab podcast. Please stay tuned for part 2, coming up next.